So the 8A family is in a park and they are playing with the ball. So they are playing with the ball. So somebody among the 8A students kick the ball. So they kick the ball going from here to that way. So actually the ball traveled from this position to that position and it covered a certain distance. But we are after this ball is how much, how far it will go, and we are going to study the projectile motion. So in this case, the ball is what we call the projectile. Our ball is a projectile. It is the object that travels a path because of the certain angle upon the ball, upon which the ball has been kicking. So the angle determines the direction of the ball as it travels in the trajectory. The trajectory is the projected path of the projectile. So that is the expected path of the ball to travel. So if you go and put the ball here and it was kicked, it would go that way and go that way. So the ball has its velocity because the ball kicked it. So that is equivalent to the magnitude of its original velocity, and it goes that way, going up because of the angle. So but actually the ball is moving into 2 dimensions because it has its upward velocity, which is Vy. You see that it's moving upward in a way. So and as the ball moves, so if you try to trace the shadow of the ball, it will cast a shadow on the x-axis and it will have its velocity along the x-axis, meaning to say there is also a movement in the x-axis. How do we get this y and x component of the velocity? The y component is actually equal to the original velocity or the initial velocity multiplied by the sine of the angle. So I'll put it here. The equal sign here, and the velocity along the x-axis is given by the cosine function. So here, that is dO cosine theta. That's it. So if you would try to calculate, you just have to multiply the initial velocity multiplied by the sine of the function. If you're trying to look for the Vy, and if you're trying to look for the Vx, you have to do initial velocity multiplied by the cosine of the function. Now let us see how high will this ball go. So imagine that it travels that path, and at quite some time it will reach its maximum height. So it cannot go any further because if it will not stop, it won't go down. So the velocity on top, or the v top, is equivalent to 0 meters per second, and that is the Vy during that time because it stopped ascending or increasing its velocity along the y-axis. And when the time comes, the ball is at its maximum distance from the ground, from here to that position. So that is equivalent to the distance along the y-axis, which is equivalent to the maximum height of the ball from the ground. That's it. So how long it will take for the ball to reach that position? How long? So you are asked to find the time. So because the final velocity of the ball is equivalent or is given by the formula gt multiplied by Vy, we can manipulate this formula to come up with, there you go, the time to get up is equivalent to Vyi, or the initial velocity along the y-axis, divided by g. So the value of g is equivalent to 9.8 meter per second squared. So you have to divide Vyi divided by 9.8 meter per second squared, and that is the amount of time that it will take for the ball to reach its maximum height. So, in this case, due to the pull of gravity, there's the pull of gravity over there, and we know that it is going downward, but this ball won't go that way, but rather, it will move that way. So, the time that it takes for the ball to reach this position is also the amount of time that it needs for that ball to get down to its initial level, or at the same level. So, meaning to say the total time of travel is equivalent to, so we are trying to look for the total time, so that's the total time. So that is equivalent to twice the time it needs for the ball to get up. So that's our formula. Total time is equivalent to 2t up. And we know that the time that it takes for the time to get up is equivalent to VO or VY, VO sine theta all over the pull of gravity. So we can manipulate again the equation to have this formula. 2VO sine theta all over the pull of gravity will be equal to the time for the ball to get up. So during that time, the ball is on its maximum distance away from the origin, or away from where it originated. So the ball is around here. So the ball has traveled a certain distance in the x-axis, which is what we call the range. So dx, or the distance along the x-axis, is equivalent to our range, which is equivalent to the velocity of the ball in the x-axis multiplied by the total time. There you go. So that is how you find the range. If you will simplify this equation further, you have Vx multiplied by the total time. So therefore, you have VO cos theta multiplied by 2VO sine theta all over g. If you know a little bit about trigonometry, this equation would yield VO squared sine 2 theta all over g, and that is the distance. But if you do not know that, you'd rather have Vx multiplied by the total time, or multiplied by 2t up, and that's how we get for the maximum height and the range, the y component, the x component of an object which is in projectile motion. This technique is in part of Sir Gerald B. Bagos. So he showed me one technique and I just copied it here. Thank you for watching.